Okay. See in this question, the correct option with respect to Pauling electronegativity values of the elements. So what are the elements they have given? First one is aluminium group, gallium, silicon, phosphorus is there, aluminium, silicon is there, silicon, sulfur, oxygen, sulfur not is given. Yeah, sulfur is also there, sulfur, selenium, tellurium there, silicon, germanium is there. Okay, so we have to compare this. See the first one. In a period elements, okay, in a period elements, electronegativity values are increases. Electronegativity increases. So in a period elements, from left to right, electronegativity increases. Phosphorus and sulfur, which one has greater electronegativity? Sulfur has greater electronegativity. So that's why first one is wrong. Then second one, silicon and aluminium. So same, silicon has greater electronegativity than aluminium. It is also wrong. Then third one, tellurium has in a group element from top to bottom electronegativity decreases. Group elements electronegativity decreases. Selenium to tellurium, which one has greater? Selenium has greater. So that's why third one also wrong. Then fourth one, so germanium in a period, these are period elements, germanium has greater electronegativity than gallium. This is correct. Okay. So the next one is the element with Z atomic number 120 not at this code will be an unknown. So how to find out? For example, I will write down the first. If you want to write down, if you can write down the electronic configuration. So I will give you how to write the electronic configuration up to 120, also very easy. So that is make a circle, 1 2 3 4 5 lines make there, and then 1s, 2s, 3s, 4s, 5s, 6s, 7s, 2p, 3p, 4p, 5p, 6p, 7p. Next 3d, 4d, 5d, 6d, 4f, 5f. You can write down the electronic configuration of based on this. Otherwise, another way is, for example, they have given alkali and alkaline earth metals. We can choose easily. So lithium, sodium, potassium, rubidium, cesium, francium. See their atomic numbers. Lithium is 3, sodium is 11, potassium is 19, plus 18, 37, again 18, 55, and then 32, 7, 87. Okay, then second group, alkali metals, we have written alkaline earth metals. The next one, beryllium, magnesium, calcium, strontium, barium, radium. So just next element, 12, 20, 38, 56, 88. Okay, so the next element, so after this one also you have to add 32 more, then it becomes 9119. So here it is 120. That means 120 an element belongs to which one? That is 2A group elements, that is alkaline earth metals it belongs. Okay, then which of the following has the highest first ionization energy? Already we discussed this one, it was given in 2016. So first group elements, so here sodium, potassium, rubidium, these are 1A group elements. They are having very least ionization energies. First ionization, least IE1. So sodium, potassium, rubidium are first group. Highest is scandium. Then, so here they are asking the ionic radii of nitrogen 3 minus, O2 minus, F minus. So the thing is, in case of anions, N minus 3, oxygen 2 minus, F minus, N 3 minus. See the negative charge. If the anion case increase in the charge, anion size, anion case, size and charge. Size is inversely proportional to, anion case, size is directly proportional to charge. Okay, so that means the increase in the charge, size also increases. So that means which one is the highest charge here? Nitrogen 3 minus is having greater charge and also size. So then here they have given three values. So respectively means first value is for first one, second value is for second one, third value is for third one. So nitrogen case is the first one, it must be the value is biggest one. So they have given the values 1.71, 1.4, 1.36. And first one must be the biggest one and last one must be the smallest one. The biggest one first values are C and D is there. Okay, next one, smallest must be the last one. So it is 1.71, it is 1.36, in between them 1.4. So the answer is C. Yeah. So the next one is which of the following represents the correct order increasing order of first ionization enthalpy? What are the elements they have given? See there. So the first one is calcium, barium, same group, sulfur, selenium, argon. Okay, so irrespective of this one, you can see that argon is a noble gas. That's why in all orders argon is having highest ionization enthalpies. Calcium to barium, okay, size increases. So that's why calcium is having highest ionization energy, barium is having less ionization energy. That means in all these elements, barium is having the least ionization energy. You can find out easily. So the order which has the barium has the least ionization energy. This is the order. So simple way to find out. Then next one, the first ionization potential of sodium. What is the meaning of ionization potential? When sodium is in gaseous state, neutral atom, if it loses one electron, it forms Na plus and E minus. So for example, it is delta H, ionization energy, what they have given, plus 5.1 electron volts. So that is the ionization energy they have given. What they are asking, electron gain enthalpy of Na plus. Electron gain enthalpy means, so neutral gaseous ion, so whatever, if you add one more electron, it forms sodium. Anyway, you have to remember that in thermodynamic process, whatever the reaction will be reverse, the sign will become reverse. So delta H is nothing but minus 5.1 electron volts. Okay, so it is ionization energy, it is electron gain enthalpy. For the same reaction, same thing, this is a backward reaction case, sign becomes opposite. So that's why the answer is minus. So here they have given plus 1, 5.1, then the answer becomes minus 5.1. Okay, so that is about up to these things are JEE mains, and then we are going to discuss some AIEEE questions also. Okay. Okay. So these are the questions from AIEEE, because up to from 2013 we have JEE mains question, and before 2013 they are AIEEE. Okay, the increasing order of ionic radii of the isoelectronic species. So they have given so many ions. They have mentioned that they are isoelectronic. So in that case, increasing order they are asking. That means always you have to separate it down. That is, anions are always bigger. Okay, anions are always bigger than cations. Okay, so that's why the first anions will come, size case. Next one, in case of anions, so what about the size of the anion is, anion case, size and charge are directly proportional. Cation case, size and charge is inversely proportional. Okay, so you have to remember these two for case of anion and for case of cation. So in case of anion, charge increases, size also increases. That's why anions are bigger than cations. So S2 minus is bigger than Cl minus. And the next one, in case of cations case, so smaller charge, which one has smaller charge? That is the bigger one, K plus, and calcium 2 plus is the smallest one. So the order is this one. So calcium 2 plus, K plus, Cl minus, S2 minus. So this is the answer. Okay. So the next one is which of the following order represents correct sequence increasing order of basic nature? So what are the oxides they have mentioned? So Na2O and MgO and Al2O3 and K2O. So these are the oxides they have given. In case of oxides, so in a period case, the basic nature decreases. Basic nature decreases. But in group case, basic nature increases. So that means potassium oxide is a strong base than sodium. All the remaining are weak bases. That means potassium oxide is strong. This is the order. So that means first one is potassium oxide. Next one is sodium oxide. Where is the answer? Yes, sodium oxide. Next one, reverse they have given, magnesium oxide. Final least one is aluminum oxide. So this is the correct answer. Next, here the correct order of electron gain enthalpy of fluorine, chlorine, bromine, iodine. This one is very important one, because the electron gain enthalpy usually fluorine, chlorine, bromine, iodine. So these are same group elements. So in a group elements, usually the electron gain enthalpy decreases. Okay, electron gain enthalpy decreases. Like that, fluorine, chlorine, bromine, iodine. This should be the order, but this is not correct, because in case of halogens, second one is having highest electron gain enthalpy than fluorine, bromine and iodine. So this is the perfect order. Okay, chlorine is having highest electron gain enthalpy than fluorine, than bromine and then iodine. So this is the answer. Why second element is having the highest electron gain enthalpy? That is, in case of fluorine, electron-electron interelectronic repulsions are maximum. Okay, because of interelectronic repulsions, fluorine is having less electron gain enthalpy than chlorine. That is the reason. Next one is same, the correct order of decreasing in ionic radii of the elements. So what are the ions they have given? Decreasing order. They are asking decreasing order. That means the first one is the biggest one, next one is the smallest one. That means they have given oxygen 2 minus, F minus, Na plus, Mg2 plus, Al 3 plus. See there, anions comes first, because with the anions case negative charge, more the negative charge, bigger the size. Then cations case, more the charge, smaller the size. So small charge, bigger the size. This is the order. So which one? See there. So this is the similar question. Okay, you can answer this one. Work out that which one is the answer. So similar question, same there. Lithium, beryllium, sodium and magnesium. Lithium, next one beryllium and sodium and magnesium. So they have given this one. So in these four, lithium to sodium, the size is increases. So that means lithium is the smaller than sodium. Lithium to beryllium, size decreases. So lithium is then this is the size. Beryllium to magnesium, size increases. See this one, all these beryllium is the smallest one among all. Which one is the biggest one? From sodium to magnesium, size decreases. So the biggest one is sodium and next one is smallest one is beryllium. So these are the two options. So in these two cases, which one is the biggest one is sodium and smallest one is beryllium. So you can understand this thing. Next, same set. Which are represents isoelectronic species? Very easy. K plus, Cl minus, Ca2 plus, scandium 3 plus. How many electrons are available? Potassium 19 plus 1 means it loses 1 electron. 18. Chlorine 17 gains 1 electron. 18. 20. Calcium loses 2 electrons. 18. Scandium 21, it loses 3 electrons. 18. So all of them are having 18. You can check the remaining how many electrons are there. Then The ionic mobility of alkali metals in aqueous solutions is maximum. So in case of alkali metals in aqueous solution, so aqueous solution actually lithium plus, sodium plus, potassium, rubidium, cesium plus. So you know the size is increases. Size increases. That is a normal case. But in case of aqueous case, that means lithium is heavily hydrated. That means lithium water hydrated. That means total water molecules. So heavily hydrated because of small size. Cesium is not, almost not, it is not hydrated. Lithium, compared to lithium to cesium, cesium size is bigger. But hydrated ion case, lithium hydrated ion is very bigger. It is a reverse case. So size decreases. In case of which one? Aqueous ions. That is important. Aqueous ions case, lithium is heavily hydrated, so its size is bigger. Cesium is not much more hydrated. It doesn't almost hydrated. It's compared to hydrated ions case, the size is opposite. So which one can easily move? Mobile means a smaller one. In case of water, cesium is the smaller one. Then rubidium, the size, that means they doesn't give the cesium. So rubidium, the next one. So lithium to rubidium, hydrated ions case. So that is the rubidium is the